Okay, so we're going to look at cross sections. We're going to give you a chance to answer these questions before I go through the solutions. So press pause now and have a go at the first question there. Move down and again, press pause, have a go at that question there. Again, press pause and have a go at these questions. And in this question, if I call the number in the middle n, can you tell me what the entries in these positions would be in terms of n? So try and write those, and then try and write the total for that cross in terms of n if you can. And then lastly, we're going to look at possibly a different kind of shape. So you're going to choose a different kind of shape, maybe like an L shape like this. Maybe that one could have a number 43, the bottom left corner of the L, and try and do all the mathematics above and find a rule for the total of L shapes like that possibly, or just choose a shape of your own if you want to. And in a moment, I'm going to go through the answers to all of these, but press pause and have a go at all of those questions first. Good luck. So now time to go through the answers. So you should have had a good go at these questions before you get to this point here. This cross has a position number of 15 because 15 is the number in the center of the cross there. What's the total of the numbers inside? You could just go through and add up all the numbers just like this. 16 plus 25 plus 35. You might want to add it up in columns as well, I suppose, but you might spot that 14 and 16, well, that's 30. 5 and 15, well, that's 20. So we've got 30, we've got 20, and then 25 plus 35 is 60. So overall, we've got 110, which was your total for this cross. Moving down, you can see that we've got a cross position of 12 to do next. So if I look at where 12 would be, cross position 12 would be right here. There we are, there's cross position 12. And you're finding the sum of these numbers. You could, again, just go for 2 plus 11 plus 12 plus 13 plus 22 plus 32. Think of clever ways to add them together. Or you may just add them together in columns or whichever way you want to, but the total of those numbers is 92. And for cross position number 13, you'd have 3 plus 12 plus 13 plus 14 plus 23 plus 33. But if you started to write these things out, and this is why writing things out in mathematics sometimes really helps, you will see a connection, I think, with the sum above. 14 plus 23 plus 33. I think you can see, and this is why working in maths is so important to write out, you can see there's a link there, isn't there? All of these numbers are just one bigger than the number above. And there are 6 of them. So each one is one bigger, and there are 6 of them. So I think that sum is going to be 6 bigger than the one above. So the sum for a 13 cross will be 98. The 14 position cross, again, you'll be able to see there that it's 4 plus 13 plus 14 plus 15 plus 24 plus 34. It's one, each of them is one bigger than the previous. Again, that power of writing down working in mathematics allows you to save time there because you can just add 6. And that confirms also that position number 15 is 110. When the cross moves one place to the right on the grid, what happens to the total of numbers inside the cross? The total increases by 6. Explain why this happens. Why does that happen? Well, it happens, I think, because we've explained up here, haven't we? We've noticed that each one of these gets one bigger. Each one gets one bigger. Each one gets one bigger. So if there's 6 of them all getting one bigger, then of course we're going to add 6 in total. Yeah, so we can write something like that. So each square in the cross shape increases by 1, and there are 6 numbers in each cross. Something along those lines would explain why that happens. Next, this is where it gets a bit more challenging. What is the connection between the cross position and the total of numbers inside the cross? So I think we've just worked that out above, haven't we? That was 110. That was 6 less. That was 6 less. And that was 6 less. Now, this is the work which is a little bit more challenging. We can see there's an increase of 6 each time. And we should know that that has a link with the 6 times tables. A number pattern that increases by 6 each time is something linked to the 6 times table, multiples of 6. Okay, we're increasing by 6 each time. That's something to do with multiples of 6. So that common difference, that's the phrase there, it's called a common difference, gives us a wonderful link to this rule. It's something to do with the 6 times table, but we're putting in the cross number. The cross number is going in, and the total is coming out. We've got a cross number of 12, 13, 14, and 15 going in, and the sums coming out. The totals are 92, 98, 104, and 110. We know it's something to do with the 6 times table. 12 sixes are 72, 13 sixes are 78, 14 sixes are 84, and 15 sixes are 90. And so you'll be able to spot, I think, there what goes in this part. We need to add 20 to get through there. So what is the connection between the cross position and the total numbers inside the cross? So I've called it cross number there. I should have put cross position, apologies, but I could call that something like cross number N, and total I could call capital T, and then we'd have something like N times 6 plus 20 equals T, if you're able to use algebra. If not, you can just use a sentence, something like the cross position or cross number times 6 plus 20 is the total. Okay. Some of you, if you've got more advanced algebra, could write something like total equals 6n plus 20, but anything like that, either in words or in symbols like this, or in nice clear algebra like that, is absolutely fine. Use your rule to find the total of the numbers for the cross position 33. So if we've got a cross position of 33, I've called that n. So is the cross position 33? It's something like 33 times 6 plus 20 would give you the sum there. So what is 33 times 6 plus 20? I'm actually being a bit naughty and just quickly using a calculator for that. It would be 218. A cross has a total of 308. What is the cross position? Well, in this case, I'm looking for a number. I could call it n. If you're not so happy with algebra, you could just call it a question mark. And I want to multiply that by 6 and add 20, and I want to get 308. Now, you don't necessarily need algebra to do this. This is what is very, very cool about mathematics. What we've got at the top there is our rule as a machine, if you can remember, as a kind of function machine. So let's just clear some space here. Let's rub that out. There we go. And I'm just going to look back, and up here I did it as what we call a function machine here, or a rule in boxes. And it's times 6 plus 20. So what I want is, I've got this rule that if I go with the cross number n, so the cross number, if I multiply by 6 and add 20, I get the total. But now I've been given the total 308, and I want to find the cross number. Well, we could just do the opposite. Now this is where maths starts getting really cool, because I could just do the opposite, you see. I could just do the opposite. What's the opposite of adding 20? Subtracting 20. What's the opposite of multiplying by 6? Dividing by 6. So I've got the total 308, and I want to find out the cross number. Let's do the opposite. 308 subtract 20 is 288. 288 divided by 6, again, just going over to the old TI-84 here. My calculator, 288 divided by 6, 48. So that confirms that my cross number of 48 would give me a total of 308. And I could check that by multiplying 48 by 6 and adding 20, and I'd find it. So cross position 48 has a total 308. If we look all the way back up here, cross number 48, there it is. If I mark that up, cross number 48 would have a total of 308. You can check that out if you want to. So that's a cool piece of mathematics there. The next part I asked you to do is to think about, if you can, this is just getting a little bit tricky now. If I call that number n, can I write down what would be in these boxes? So if that number was 15, if you remember, this number was 5, wasn't it? It was 10 less. In the 100 square, if I just quickly look below at the 100 square, in the 100 square, if I pick any number in the 100 square, the one directly above is 10 less. The one directly below is 10 more. The one 2 below is 20 more. The one to the left is 1 less, and the one to the right is 1 more. So how do I write that in algebra, in mathematics? This is now using algebra. Well, 1 less I write as the number and 1 less. 1 more I write as the number and 1 more. 10 less I write as the number and 10 less. 10 more, that's n plus 10. 20 more, n plus 20. So very well done if you got that. The total, of course, then would be to add all these up. Well, that would be n minus 10 plus n minus 1 plus n plus n plus 1 plus n plus 10 plus n plus 20. And if you do know a bit of algebra, you've got n plus n plus n plus n plus n plus that's 6n. Now, can you guess what the numbers will be? Yeah, well, minus 10 plus 10, that's 0. Minus 1 plus 1, that's 0. But there's a plus 20. And that makes us very happy, of course, because it's exactly the same as the rule we achieved here. So all of this mathematics now connecting together in a very cool way. And then for the further extension, I asked you to think about a different shape. There's a different shape. I just made it up. It's an L shape. This L shape would have number 43. I decided the bottom left. But you can choose any shape you want. What would the sum of this shape be? Well, I can add up the numbers. But I know also that if I call that bottom left n, I call that bottom left of the shape n, then just above it I'd have n minus 10. Another one above it would be n minus 20, and another one above it would be n minus 30. To the right would be n plus 1, and then 2 to the right would be n plus 2. So I can find the sum of my L shapes in algebra, and you can repeat all of those steps above for any shape you choose and make a generalization that links the number of the shape, whichever part of the shape you choose of the label. I chose the bottom left, with the sum. And in this case, I think I'd have 1, 2, 3, 4, 5, 6 ends. Again, there's 6 squares. 1, 2, 3, 4, 5, 6. That's right. And then I'd have, what would I have? 6n minus 30, 40, 50, 60, minus 60, but plus 3. So minus 57, I think. But you can choose a shape and have a go at one of your own. If you've got all of those answers, that's fantastic. Well done. Brilliant. And hopefully you've had a good go at that. Thank you.